Swayam Prabha. Digital India. Educated India.
Yeah, good morning. So, welcome to the course on comprehensive view of speech processing. So, today's lecture is the 12 in series, and today we are going to discuss about the properties of linear time invariant system, to be LTI system, and in the process we introduce the concepts of convolution and correlation. So, in the last class we discussed about processing of speech. Basically how to acquire the speech using a microphone, and then the acquired speech is basically analog in form. So, then for processing that speech analog signal by machines, we need to have digital representation is required. So, we also discussed about how to digitize the speech signal using analog to digital conversion, what are the various steps involved in that. So, all those topics we discussed in the last class. And also we also introduced a concept of unit sample and its representation. Unit sample, we defined what is meant by unit sample and its use in representing a discrete time signal. So, any discrete time signal can be represented as a linear combination of scaled and shifted unit samples that we have seen or discussed in the last class. We started from the definition of unit sample, and from the definition of unit sample we derived the expression for any discrete time signal in the form of a linear combination of scaled and shifted unit samples. So, today we are going to introduce the concept of the related to LTI system and its properties. And here we are studying the LTI system. The main reason for this in discussing this particular topic is that because here we are viewing the speech production system as speech is produced as like exciting the vocal tract system with a time varying excitation, right. Here the vocal tract system consists of oral cavity, nasal cavity, and various organs that are present in the oral cavity or in the vocal tract system. So, that will be viewed as a system, and that system is excited by different types of excitations, so voiced, unvoiced, and mixed excitation and all. So, this excitation excites the vocal tract system, and then the response of that vocal tract system in response to these different types of excitation, that can be viewed as a speech. So, that way we view the speech production system as like a combination of as a result of exciting vocal tract system, time varying vocal tract system, because here I just mentioned it's time varying vocal tract system because for production of a speech, since it is a sequence of sound units, each sound unit requires different configuration of a vocal tract shape. So, therefore, when you are producing a speech in a continuum, we have a sequence of sound units. For every sound unit, the vocal tract configuration will be different. So, therefore, it is a time varying vocal tract system and excited by a time varying excitation, right. Depending on the sound unit, the excitation also signal also will vary. For different vowels, for example, in case of voice speech, excitation is the vocal tract or the vocal folds excitation offered by the vibration of vocal folds, whereas in case of other sound units, the excitation will be constriction in the oral cavity at different places. So, that way in that context, first we introduce the concept of LTI system, then afterwards we will approximate the speech production system as a combination of a piecewise linear combination of like the LTI systems in sequence. So, here the LTI system means linear time invariant system, as I mentioned here, and here an LTI system is defined as suppose a system has some true response known to be h of n is the response of the system, are known to be the true behavior or the true characteristic of a system, are known to be true response of a system h of n. And the system will be excited by different inputs or different excitation signals, right, and accordingly the output y of n will be. Accordingly, the output of a system or the response of a system with respect to various inputs will be viewed as a y of n. And here the true response of a system will be exhibited if we excite the system with the unit impulse or unit sample, or in case of discrete time signal it is known to be unit sample. So, if you excite the system with a unit sample, so whatever the output you observe, so that output is nothing but the true response of a system or the inherent response of a system or a true behavior of a system. So, therefore, so you can able to see the true response of a system when you excite the system with a unit sample. So, therefore, this h of n is also known to be unit sample response, unit sample, because this is the response that is observed when you excite the system with a unit sample, right. Other than unit sample, whatever the input you will give, then the system response will be like the response of the system, and also the characteristics of the excitation is also present in the output response of a system. And so, that way h of n is defined as the system unit sample response. And now we will see that suppose if you give the input as x of n other than the unit sample, right. So, x of n is a discrete time signal, right, and here we are discussing the system or the signal or the output, everything in the discrete, everything in the discrete time domain, discrete time domain. So, your x of n is a discrete time signal, some discrete time signal used as input exciting the system, and h of n is the response of a system, or you can say that the true response of a system are known to be unit sample response, and y of n will be the output for the given x of n. And now here you see that we know that from the definition of LTI system. So, if you provide the input as the unit sample, so the output, the y of n is nothing but your h of n, like it is nothing but the true response of a system, right. And then here instead of delta of n, instead of sample unit sample input, so I am just here just shifting the unit sample by k, just shifting the unit sample by the k units or the k instants in the positive direction, right, delta of n minus k, because we have seen that delta of n minus 1 is nothing but the unit sample at n equals to 1. So, likewise here delta of n minus k means the unit sample at n equals to kth instant, n equals to the kth instant, right. So, if you for a unit sample the output is h of n. So, therefore, if you shift the unit sample by k units or by k instants, so delta of n minus k, for that the output will be h of n minus k, because since it is LTI system. So, if there is a shift in the input, so you can able to see the shift in the output also. So, we know that when the delta of n, the output is h of n, and here we have shifted the sample, unit sample. So, for this the output response will be h of n minus k, because this is based on the property of the LTI system. So, for the property based on the LTI system, linear time invariant system, if there is a shift in the input, you can able to see the output is also shifted by the same amount as the input shifted. And now the next one is that we have a shifted unit sample, and now the shifted unit sample is scaled or is multiplied by some constant, or is nothing but a scaled and shifted unit sample. The input we are giving is scaled and shifted unit sample. So, if you give the scaled and shifted unit sample as per the LTI system characteristic property, the output is also behave the same way. That means, we know that when the unit sample is shifted, the output is also shifted by same amount h of n minus k. And now what you are doing here, the shifted sample is scaled, that means the amplitude of the unit sample now scaled by a factor xk, scaled by the value x of k. So, now its corresponding output is also like h of n minus k scaled by x of k or multiplied by x of k, right. And then that means, when the input to a LTI system is a scaled and shifted sample, then the output is x of k into h of n minus k. And now I am just representing this x of n. We know that earlier in the last class we already discussed, we already shown also, x of n is nothing but the linear combination of shifted and scaled unit samples, linear combination of shifted and scaled unit samples, right. So, that you can able to see now here, if the input is like shifted and scaled and shifted unit sample and summation of those scaled and shifted unit samples. So, that becomes my x of n, this is my x of n. Suppose if you give this as the input, so my output behaves the same way, because here so far we have only one sample we have given as the input, and here we have given the, we are giving the a sequence of samples we are giving input. That means, we are giving multiple inputs where each input will be shifted by some amount and scaled by some amount. So, that way this summation of x of k into delta of n minus k over k is nothing but we are applying the multiple unit samples with different shifts and with different scaling factors. So, by providing the multiple inputs, then the output will be again a combination of the responses of the scaled and shifted unit samples, whatever the way. So, that you can able to observe over here. And now, if you see this combination of scaled and shifted unit samples are nothing but my discrete signal x of n, because I can write x of n as a summation of scaled and shifted unit samples, right, that we have observed in the last class. So, this is my x of n. So, if you give x of n as input, so my output is this one, like x of k into h of n minus k, where k varies from minus infinity to plus infinity. So, this is nothing but my output, this is nothing but my response of the system, my response of the system, output response of the system for the input x of n. So, we know that for an LTI system, the output response depends upon the input and the sample or the unit sample response using a convolution. That means, you know that y of n is nothing but x of n convolution with h of n. This is a star is nothing but convolution symbol, star is a convolution symbol, right. So, here, so for an LTI system, linear time invariant system, so the output response of a system is nothing but the convolution of the input with the unit sample response, the convolution of input with the unit sample response. And we know that this y of n is nothing but this one, this expression. So, therefore, the convolution of the input and the unit sample response is nothing but you can able to evaluate by using this expression. So, x of k into h of n minus k, where k varies from minus infinity to plus infinity, minus infinity to plus infinity. So, therefore, here just see that I are introducing the concept of convolution just from the basic definitions. One is that LTI system, a definition of LTI system, linear time invariant system, and second one is the concept of unit sample. So, using a concept of unit sample, we represented the discrete time signal as a summation of a shifted and scaled unit samples, summation of scaled and shifted unit samples. So, this we have derived, and then these are the properties of LTI system. That means, the input is shifted, the output also will shift by same amount. If the input is scaled, then output is also scaled by same amount. And if you have multiple inputs offered to the system simultaneously, then the output will be a combination of the responses of the inputs, the corresponding inputs. Suppose if there are two inputs simultaneously given, then the output will be the response of the individual inputs, the combination of individual the inputs, right. So, the same way here we have derived. So, therefore, the y of n is nothing but the convolution between the input and the unit sample response. So, here the input is a discrete time signal and your unit sample response is also a discrete time sequence, discrete time. So, it is nothing but a convolution between the two sequences, convolution between two sequences, and the formula for evaluating the convolution between the two sequences is this one, x of k into h of n minus k, y of n. If you give different values of n, right, and then you can able to evaluate each time for different values of n. When you put n equals to 0, then you plug in n equals to 0 here, then this becomes x of k into h of minus k over the interval over the summation k varies from minus infinity to plus infinity, right. Likewise, when n equals to 1, this becomes 1 minus k, when n equals to 2, this becomes 2 minus k, and so on. And here the factors, the sequences x of n and h of n, this can be convolution in either way. That means, here you see that x of k we fix, and then h of n minus k we shifted the h of we vary this one. The same way we can also do the other way also, h of k into x of n minus k, both results the same. Either way you can do it. That means, convolution of x of n or h of n is like symmetry, like you can do like h of n convolution of x of n is same as the x of n convolution with h of n, right. So, this way we can like introduce the concept of convolution, which derived from the basic properties of LTI system and all. That means, here in the time domain, if you want to find out the response of a system for a linear time invariant system, so the response of a linear time invariant system is nothing but the convolution of the input, nothing but the excitation or input with the true response of a system or a unit sample response, right. So, that way you can able to find the output or the response of a system for any response of an LTI system for any input, if the input is given in the discrete time signal. And now, let us see, this is the time domain way of analyzing the LTI system. Suppose we want to analyze the LTI system in the frequency domain. So, in that case what we can do, because these are the time domain signals. So, if you apply a Fourier transform, if you apply the Fourier transform on this discrete time signal, then you can come to know about like what will be the output response of a system, or you can say that. So, if you compute the frequency domain response, or if you compute the frequency domain representation of y of n, right, using a Fourier transform by using appropriate relations, then if you just plug in the Fourier transform expression for this input, you can able to observe that the y of omega is nothing but h of omega multiplied by x of omega. So, what it means here is that for an linear system, linear time invariant system, in a frequency domain, the output response is nothing but the product of the x of omega, that is the frequency domain representation of input, and the frequency domain representation of h of n. So, h of omega is nothing but, if you apply a Fourier transform for h of n, so the result will be h of omega. Similarly, x of omega is nothing but, x of n is a discrete time signal. If you apply a Fourier transform on x of n, so the result will be x of omega. So, what it means here is that in case of LTI system in a frequency domain, so the y of omega is related to the input and the system response in this way. The y of omega, that means output in a frequency domain, the output the signal in a frequency domain is nothing but the frequency domain representation of input multiplied by frequency domain representation of h of n, or nothing but the unit sample response. So, this is easily you can able to derive, it is no difficult at all from the definition of Fourier transform. We know that the convolution relation like y of n is nothing but convolution of x of n and h of n. So, this expression will be placed in the Fourier transform relation, and then if you simplify that, you can come to know that. So, the output, the y of omega is nothing but h of omega multiplied by x of omega. And here along with the concept of convolution, I am just introducing one more concept very much similar to the concept of convolution, known to be correlation, So, here correlation means basically the concept of correlation will be used to analyze the two signals, the similarity of two signals, or similarity of a pair of signals. So, suppose for example, here x of t is a signal, one signal, and y of t is another signal, and if we want to see a similarity between these two signals, so if you apply a correlation, if you analyze the correlation between these two signals, so the correlation can be evaluated using this expression. So, C of t is nothing but a correlation between x of t and y of t, correlation between x of t and y of t. So, C of t can be evaluated as x of t multiplied by y of t plus tau d tau, y of t plus in a continuous time. Suppose if these two are the continuous time signals, then the correlation between these two signals are evaluated by using this expression, product of x of t into y of t plus tau. Y of t plus tau is nothing but the shifting the y of t signal by the amount tau, by a shift of tau, d tau, shift of d tau. Like here we can see that for different values of t, you can able to find out the correlation between x of t and y of t, and then by observing the C of t, then we can come to know that whether these two signals are like correlated, there is a similarity between these two signals, and what is the amount of similarity. So, all those things you can able to analyze by observing the signal C of t and all. So, this is a continuous time, and its equivalent in the discrete time or a discrete signal will be this one. C of n is nothing but summation x of n into y of n plus k, x of n into y of n plus k. So, this is very similar to the convolution. Here in case of convolution, this is h of n minus k, whereas here it is a y of n plus k, right. So, other than that, both the convolution correlation, they resembles very similar, right, and this is the correlation between the two signals x of n and y of n in the discrete domain, C of n in a discrete domain. So, these are the same expressions I just mentioned here with a highlighted fashion. So, we will see that what is correlation and what will be the use of this one, we will see in a later slide. And since the correlation with in view of formulation, it is very close to the convolution, except there is a sign change over here. Other than that, the formulation or the expression of correlation is very similar to the convolution. So, that is the reason that I just introduced a concept of correlation over here. So, as I mentioned here, correlation between a pair of signals is used to indicate that how these two signals are similar. Suppose the signals are not at all similar, then the result of correlation value will be very less, you will get a negative. Suppose the two signals are very different, like very orthogonal, then in that case if you compute a correlation, you will get a value -1, you will get a value like very negative, negative value and all. If two signals are identical, if the two signals are equal or very similar, then if you compute a correlation, you will get a larger value, you will get a larger value, larger positive value and all. So, that way one can able to estimate a correlation, and from that one can able to comment on. So, whether the two sequences or the two signals, whether they are similar or they are very different, that you can able to comment by observing the correlation. Yeah. So, we can able to compute a convolution using the formula given, like here for example, you can see here, suppose just take an example, x of n is a discrete time signal, where the signal discrete time signal where the signal is observed at the 3 instants n equals to 0, 1, 2, and these are the amplitudes. At n equals to 0, the amplitude is 1, at n equals to 1, the amplitude equals to 2, and at n equals to 2, the amplitude equals to 1. That is, x of n equals to 1, 2, 1 means the signal is present at 3 samples at 3 instants, and the rest of the time the signal is 0, right. So, that way you can view the signal x of n like this, and this is pictorial, you can view the x of n. And let us take the other signal h of n, right, other signal h of n, as here in this context h of n is present at 4 samples, 4 instants at n equals to 0, 1, 2, 3 and so on. So, this is pictorial representation of h of n, right. And if you want to compute the convolution between these two, if you want to compute the convolution between these two by a linear time invariant system, you know, y of n equals to x of n convolution with h of n, and this is the formulation to evaluate that. So, here we know that for different values of n, if you plug in different values of n, and you can able to using a formula or using this expression, you can able to evaluate the convolution, you can able to evaluate the output sequence, the output response is nothing but a convolution of between these two, right. So, y of 0 is nothing but x of k into h of minus k, right, because n equals to 0. So, this becomes h of minus k, and y of 1 is nothing but x of k into h of 1 minus k, and here the summation is there. I am not mentioned here, but the summation is here, right, and y of 2 is nothing but x of k into h of 2 minus k, and so on likewise, right, and similarly for other values also. Likewise, by plugging different values of n, and in this expression you can able to compute the corresponding values of x of k and h of k, and then take a product of that. That way you can able to get the convolution output, or you can say that the output response of a system and all. It is nothing but convolution of between these two sequences. And now here this way, by using expression you can able to evaluate the convolution, right, and you can also visualize how this convolution is performing. Like this is a mathematically you can able to evaluate the values of a convolution sequence, or you can say that the output sequence, output response y of n. I am saying here I am just using the terms like a convolution sequence, output response, both are one and the same, because output response is nothing but for an LTI system, it is a convolution of the input and the unit sample response, right. So, therefore, I am just saying that the convolution sequence is nothing but the convolution of h of n and y x of n. This is nothing but output response. So, for output response for different values of n, when you plug in n equals to different values, you can able to compute you can able to evaluate these expressions, and you can find determine the response of a system. And the same thing you can able to visualize in a graphical way how this convolution is performing, right. So, by looking at here you can see your if you observe y of n is nothing but x of k multiplied by h of n minus k, h of n minus k, where the summation over k equals to minus infinity to plus infinity. And here this n minus k is nothing but like it is nothing but you are shifting the like h of minus k for different positive values of n and different negative values of n, right. This h of n minus k realization can be realized, can be viewed as you have h of minus k, and then by plugging different values of n, this h of minus k sequence is shifting towards positive and towards negative side. When you put n equals to 1, 2, 3 and so on, this h of minus k is shifted towards positive direction, and when you put n equals to negative values, you are shifting h of minus k in the negative direction and all. So, that way if you can able to visualize the evaluation of or the computation of the convolution between the two sequences, here you can see x of k, right, and for suppose for example evaluating y of 0, what we need to do, we have multiply x of k into h of minus k. How do you get h of minus k? H of minus k is nothing but h of k is nothing but this one, just this is h of n, but instead of index n value you can put k also, that remains same. So, h of k is this one, the value is available 0, 1, 2, 3. H of minus k is nothing but just flipping the sequence by 180 degrees, right. So, then whatever the sequence that results is noted by h of minus k, right. So, therefore, h of minus k is this one, h of minus k is nothing but just rotating this sequence by 180 degrees. So, then you will get the h of minus k, this is my h of minus k. And what is y of 0? It is a product of these two. Product of these two means in a graphically we will see that this is one signal h of k, x of k, and this is h of minus k is another signal, right. And here this signal present at 0, 1, 2, and the remaining places the signal is absent, signal is having 0 value, whereas here h of minus k is present at 0, minus 1, minus 2, minus 3, and rest of the place it is 0 value. So, when you take a product of these two, is nothing but whatever the overlapping of these two sequences, so that results the value, and the remaining places it results at 0, because h of minus k is not present at 1 and 2, and similarly x of k is not present at minus negative values. So, therefore, if you take a product of x of k and h of minus k, it results to be whatever the overlapping in the sequences, so that results the product, that product results. Here is nothing but like here the magnitude equals to 1 x of k, and here h of minus k magnitude equals to 1. So, there is a overlapping at 0th instant. So, the corresponding product will be realized and the remaining values will be zeros, right. So, therefore, here this becomes 1. So, therefore, you can see that y of 0 becomes 1, because at the rest of the places x of 1 is present k when k equals to 1, but here h of minus k when k equals to 1 it is not present, 0 value. So, therefore, these two samples will result the product will be 0, and similarly these 3 samples will result the product to be 0. So, therefore, x of k and h of minus k over a summation gives you value 1, because this multiplied by this is nothing but unity magnitude, this also unity magnitude 1. So, 1 into 1 it will be 1 will be resulted. And like for example, y of 1, what is y of 1? Y of 1 is nothing but x of k multiplied by h of 1 minus k, x of k multiplied by h of 1 minus k. What is h of 1 minus k? H of 1 minus k is nothing but h of minus k shifted by one shift in the positive direction, one shift in the positive direction. This is my h of minus k, right. H of 1 minus k is nothing but this sequence, like the same sequence we are shifting one shift in a positive way. So, therefore, you see that this sequence we are shifting one shift in a positive way, this is the h of 1 minus k. And now you see the product of these two. So, when you do this product here, if there is two samples overlap, right. H of 1 minus k is available at 0, 1 and minus 1, minus 2, whereas x of k we are not shifting at all. So, it is present at 0, 1, 2. So, there are two samples overlap. So, at 0 here h of 1 minus k has the value 2, the sample value 2, and here the sample value 1 for x of k. So, the product results to be 2, and h of 1 minus k at 1 this has a sample amplitude 1, but here this has a sample amplitude 2. So, therefore, this is again 1 into 2 will be result in this product. So, if you take a summation over k, you will get here there is two samples overlapped, and the corresponding product will give you 2 plus 2 4, will give you 2 plus 2 4. So, therefore, y of 1 becomes 4. Likewise, y of 2 is nothing but h of 2 minus k, just y of 2 is nothing but here in this expression we are putting n equals to 2, h of 2 minus k is nothing but h of minus k shifted by two samples in the positive direction, right. This is h of 2 minus k, and h of 3 minus k likewise, right. So, that way if you shift the h of minus k in the negative direction, this becomes h of minus 1 minus k, h of like. So, that way you can able to shift the other way, right, in the positive way, negative way. So, when you shift this h of minus k in a positive shift, you will get n equals to 0, 1, 2, 3, 4 and so on, like you can get y0, y1, y2, y3 and so on. And if you shift the h of minus k in a negative direction, you will get y of minus 1, y of minus 2, y of minus 3 and so on, right. But if you see that when you shift this h of minus k in a negative direction, right. So, this is the sequence, right, h of minus 1 minus k is nothing but h of minus k shifting h of minus k in the negative direction, right, in the negative direction, right. So, then in that case the sequence will be this one. So, here you do not see any overlap between x of k and this one. So, therefore, y of minus 1 will be result to be 0. So, and then if we further shift there is no overlap. So, that result will be 0, like y of minus 2, y of minus 3 and so on. But here if you shift this one like h of minus k towards positive direction, you can able to find the shift till 2. You can see h of 4 minus k, you have a like overlap at 1 and 2 samples overlap with the x of k. Likewise, h of 5 minus k also you have a overlap, because here you have a sample at instant 2 and x of k has a sample at instant 2 you can have. But h of 6 minus k, if you look at, there is no overlap at all, it will be 0, and if you further shift then the overlap, there will not be any overlap and results to be 0, right. So, if you look at this the sequence, if whatever we discussed here, y of 0 will become 1, you can see here from here this is h of minus k, right, and x of k will be there, assume x of k on top, and then you can see the overlap between them, corresponding overlaps, and you can able to see that y of 1 happens to be 4 and y of 2 happens to be 6, right, y of 3, y of 4, y of 5, and then from y6 onwards towards positive side there will not be any overlap. So, it results to be 0, y6, y7 and so on. Similarly, y minus 1 also there is no overlap at all, that we have observed, right, y minus 1, y minus 2 and so on. So, that results to be 0, it results to be 0. So, this way we can view the convolution in a graphical way. We can perform the convolution given the two discrete sequences blindly. We can able to compute the convolution using the formula that is provided, that we have derived using the expression. You can able to do that, but graphically if you want to visualize this mathematical computation, this evaluation, how graphically what exactly how it is happening is nothing but you have two sequences, discrete sequences, and in that one sequence you fix it, that means you do not change, you do not shift at all, and keep the other sequence rotate by 180 degrees, you will get like the negative of that particular sequence, like h of n means you will get h of minus k, right, you will get, and afterwards shift that negative sequence in a positive and negative direction, you will get the convolution, the corresponding convolution values at a different instance, and at 0, 1, 2, 3 and minus 1, minus 2 and so on. So, this way we can able to visualize the convolution between the two discrete sequences as like fixing the one sequence and shifting the other sequence by 180 degrees, you will get a negative of that sequence, and afterwards shift that negative sequence, right, towards positive and towards negative, and with that you can get the appropriate convolution values and all. And each shift we have to see that what is the overlap area, and then we will try to compute the overlap area between the two sequences. And here since they are discrete sequences, so the overlap is nothing but the multiplication of the corresponding samples, the overlapped samples and all. Suppose if they are continuous signals, then the area will be, we can view it like area and all, because we can visualize that as the area between the area of overlap between the two signals, and that area will be computed as a result of convolution. So, the similar way we can able to also visualize the correlation in a graphical way. As I have mentioned that the difference between the convolution and correlation will be, in case of convolution the formula will be like c of or y of n is nothing but x of k multiplied by h of n minus k, h of n minus k over a summation of k. So, that graphically we visualize as h of n minus k is nothing but, first we visualize h of minus k, that means we have like the negative of the sequence, like that is nothing but graphically is nothing but rotating that by 180 degrees, right, you will get a negative of the sequence, and then take a product of that the negative sequence with the other sequence which is not shifted at all, which is not changed at all, and this negative sequence will be slided over the other sequence in a both positive and negative, so that the overlap is present. So, at each overlap we will try to compute the sum of the products, and then the appropriate the corresponding convolution value will be evaluated. And here the correlation, if you look at the formula or the expression for a correlation, the only difference is that here in case of convolution it is h of n minus k, whereas in case of correlation it is I think but h of n plus k. So, therefore, since it is h of n minus k, so we got the sequence h of k will be rotated by 180 degrees, and then we shifted both positive and negative directions to get a corresponding convolution values. In case of correlation, since the expression equals to h of n plus k, so therefore, we need not shift the other sequence, we will keep one sequence fixed, and the other sequence it will be just shifting without rotating, just shifting the other sequence by positive or negative directions, and each shift we will see that what is the overlap, and we need to estimate that overlap, and that will be resulted as a correlation and all, that will be resulted as a correlation. So, here if you look at by taking the same example x of n and h of n, right, and if you want to perform a correlation c of n, and here the symbol I have given is that the star encircled by circle, encircled star is the symbol for correlation, and here x of n correlation with h of n, and the expression for that is x of k into h of n plus k over the interval over the summation k varies from minus infinity to plus infinity, and this is the graphical visualization of that. X of k, here x of k is fixed, and here h of k we are not rotating at all, because here this is h of n plus k. So, there is no need for rotating the other signal, just shifting the other signal by positive direction and a negative direction, and here first we are not shifted at all, and this gives you the correlation at 0 overlap or 0 instance or 0 shift, right. Multiplying these two, the sequences is nothing but whatever the overlapped samples are there, and you have to multiply their corresponding magnitudes or amplitudes. Here you can say that in this sequence and in this sequence, these three samples of this sequence overlapped with these three samples, right. So, here the correlation at a 0 shift between x of k and h of k is nothing but x of k multiplied by h of k, right, is nothing but here this is 1 into 1, then 2 into 2, right, and again 1 into 1. So, that results to be 4, right. The correlation at a 0 shift between these two sequences will be 4, and then the next shift will be h of k plus 1 is nothing but shifting h of k by in the positive direction, So, now you can see here there are again two samples overlap, 1 and 2, because the 0th sample we are shifted. So, there is no 0th sample corresponds to h of k plus 1. So, these two, so the corresponding product of these two samples, like here at 1 amplitude equals to 2, and here at 1 the amplitude equals to 1, like 2 into 1 2, and here at 2 the amplitude equals to 2, and here 2 amplitude equals to 1. So, the multiplication results to be 2, 2 plus 2 again 4, right. So, the C of 1 is also 4, right. So, likewise C of 2 is nothing but shifting further by 2 shifts, C of 3 for the 3 shifts, C of 4 likewise. So, at a C of 3 itself, if we look at here, it is shifting this sequence by 3, right. So, you can able to see that there is no overlap at all, there is no overlap, because you are shifting this sequence by 3 instants. So, now this instance starts with 3, and here my x of k is available only up to 0 1 2. So, there is no overlap at all. So, therefore, C of 3 will be resulted to be 0, because when you try to multiply here there is no overlap at all. So, there is a 0 overlap, it results to be 0, and further shifting results to be anyway 0, it is intuitive, right. And now you see that the negative shifting, right, h of k we are shifting in the negative direction. So, h of minus 1 plus k, this is the sequence, you see the overlap between these two, right, and try to estimate the product of the samples, the pair of samples of this overlapped region, and try to estimate that, right. So, that way this is h of minus 1 plus k, this is h of minus 2 plus k, and so on. If you keep on shifting here, right, up to h of minus 3 plus k you have a overlap, and when you do h of minus 4 plus k, that means when you shift this h of k by 4 samples towards the negative side, then you do not see any overlap at all. Up to 3 samples, at least you have one overlap is there. At 3 samples, at h of minus 3 plus k is nothing but the sequence is available at 0, minus 1, minus 2, minus 3. So, at 0 you have a overlap, and at minus 4 the sequence will be present from minus 1 to minus 4. So, there is no overlap at all, that results to be 0. So, if you look at the correlation values, you can see that at C of 0 it will be 6, right, and yeah, see, is it 6? C of 0 means multiplication of these with this sequence. So, you have 3 samples will be overlapped, here 1 into 1, and again at sample 1 here the amplitude equals to 2, here also 2. So, 2 into 2 4, and here the sample amplitude equals to 1 and 1, there is 1. So, the total will be 1 plus 4 plus 1, it is 6, right. So, that way you can see like C of 0, C of 1 equals to 4, right, C of 2 equals to 1, right, and C of 3 will be 0, because after you shift by 3 positions in a positive side, because my x of n is available only up to 2 instants, up to 0 1 2 only. So, therefore, C of 3 results to be 0, and then afterwards further C 4, C 5, C 6 all will be zeros. And again similarly, if a negative shift, if you analyze C of minus 1, C of minus 2, C of minus 3, you can able to see the values something like this. C of minus 1 will be 6 actually, sorry, it's not negative 6, it's 6, it's 6 only, right, because here the samples have only positive amplitude. So, their product will be result to be positive only, you do not get any negative and all, right. If the sample has negative value, then you may have a chance of negative result you may get, but since both the samples have positive values, you do not have this one. So, that way you have correlation values you can able to obtain. So, now we have seen that actually convolution correlation, the concepts are very similar. In case of convolution, graphically if you want to visualize the convolution, out of two sequences, one sequence has to be fixed, any sequence out of these two, any sequence can be fixed, and rotate the other sequence, right, by 180 degrees, then you will get a negative of that sequence, and then that negative sequence has to be shifted or slided towards positive or negative direction. For different shifts, you will get a different convolution values. And in case of correlation, out of the two sequences, and here the correlation between the sequences that matter, it will not, it is not a commutative property will not exist here. Commutative property exists in case of convolution, that means you can put any of the signal can be fixed, other signal can be rotated, right. That means either x of n convolution with h of n is nothing but h of n convolution with x of n. But in case of correlation, it is not the same, correlation will be different, right. So, therefore, in the correlation between two sequences, if you keep one sequence fixed, the other sequences should be shifted in a positive direction and a negative direction, you will get a corresponding correlation values and all. And based on the correlation value, suppose if the correlation values are positive, right, then you can able to say that, can comment that, so the two sequences have some similarity. If the correlations are the negative values you are getting, that means that the two signals or two sequences or two signals have, like, there is no correlation at all, that means the similarity between the two signals is very, very less. And if you get a very large negative value, it means that the two signals are like quite orthogonal, like quite reciprocal to each other. That is the way you can able to comment. And now, if you try to analyze the computational complexity of this convolution or a correlation, suppose for example, let us take a signal x of n, discrete sequence x of n, whose length equals to n, capital N. It means that the x of n, the signal is present at n instance, in n instance, capital N instance, right, and the other signal h of n is present in m instance, that means the length of the sequence is m. Here length means the number of instants where the samples are present, the sample amplitudes are present. So, here we can compute the convolution or correlation between the two sequences. So, here the sequence, one of the sequence length equals to n, other sequence length equals to m. Out of this, assuming that the n is greater than m. So, in that case, you can see for computing the convolution or a correlation, what we are doing here, each time for every value of convolution, we are finding out the overlapped area between the two sequences. And here in the context of when it is a discrete time sequence, the sequences, the overlapped area is nothing but the product of the sample amplitudes which are overlapping, right. So, that way when you try to analyze the computational complexity, and what you are doing for every value of convolution or correlation, you are taking a product and then the products will be summed up. That means, we will computing the sum of the products, we are computing sum of the products. It means, if you look at the earlier, this means for every correlation value, it is nothing but here you can say that it is a sum of the products x of k into h of k for different values of k, right. So, estimation of convolution or correlation is nothing but like we are computing the products and then we are summing them. So, the sum of the products will be result to be one value of a correlation or a convolution. So, likewise you need to estimate the for different values, for all existing values of the convolution and the correlation. So, as we have seen here, that depending upon the sequence, right, sequence length, you can when you estimated the correlation or a convolution here, you can see here earlier you can see for x of n the length equals to 3 and h of n the length equals to 4, right. So, when you evaluated the convolution or correlation, you can able to see that the convolution sequence will be resulted to be of length n plus m minus 1, n plus m minus 1. That means, if the one of the sequence length equals to 3 and other sequence length equals to 4, then when you estimate the convolution or a correlation, the length of the convolution sequence or a correlation sequence will be n plus m minus 1. That means, the summation of those two sequences, the length of those two sequences minus 1, because we are computing overlap between them. So, therefore, you can able to see that the when you try to estimate the correlation or a convolution, the length of the correlation sequence or the convolution sequence will be n plus m minus 1. So, that is what we observed in computing a correlation between the two sequences, where one sequence length equals to 4, other sequence length equals to 3, and when you estimate the correlation, you can able to see the correlation you can able to observe at 6 different values, right, because 3 plus 4 minus 1, right. You can see at C of 0 you have a non-zero, right, and C of 1 the correlation exists, C of 2 correlation exists, and from C3 onwards there is no correlation at all. That means, the signals are not at all overlapped, right. So, from C3 onwards the result will be 0, right. So, therefore, when you shift in a positive way from a 0 shift, there are 2 positive shifts the correlation exists, and in the negative shift you can see that there are 3 shifts the correlation exists. At C of minus 1 the correlation value equals to 6, C of minus 2 the correlation value equals to 5, and C of minus 3 the correlation value equals to 2. That means, when you shift in a negative direction, 3 shifts you can able to observe a correlation, and beyond that, if you shift further C minus 4, you can observe that the 2 sequences are not at all overlapping. So, that results to be 0, and further negative shifts anyway the overlap does not exist. So, therefore, the correlation results to be 0. So, that way the correlation sequence length will be n plus m minus 1, and for every correlation value you need to perform certain multiplications that depending upon the overlapped samples, and we know that among these 2 sequences the sequence length n is greater than m. That means, one sequence has a more slightly more length than other one, then the maximum number of multiplications that is possible that exist will be, right, this one, the n times this one, right. So, therefore, sorry, it is not n, you will get a m, the lesser sequence, because at any point of a time if you try to look at the overlap, you will get the overlap will be like whatever the shorter sequence, whatever the length of the shorter sequence, you can able to observe only that much overlap, right. So, therefore, here also it is a mistake, it is not n, this will be m times n plus m minus 1, because this is the shorter sequence, because the number of products will be result will be m, will be maximum m in each evaluation, So, here we in the computational complexity we have not considered the complexity of the sum operation, because the complexity of sum operation will be much less or negligible compared to the complexity of multiplication operation. So, therefore, here we just considered only the multiplications, number of multiplications. So, the order of number of multiplications will be m times, here is not n, this is m, and similarly this is also plus 6, this is not minus 6. So, these are the 2 corrections that can be noted from this slide. So, the same thing here I just mentioned for correlation, like the same thing, the same analogy or the same explanation can be applicable for convolution also, because for convolution and correlation the number of multiplications or the number of summations that results will be the same, exactly same, right. The only difference is that in case of convolution, as a graphically we observed that, so we have rotated the one of the sequences, and then afterwards again we shifted and then computed the overlaps between the 2 sequences, and we estimated the overlapped the product of the product of the sample amplitudes which are in the under the overlap and all. So, that way you can able to compute the compute the correlation sequence or convolution sequence. And here this is known to be the way we performed the convolution or correlation between the 2 sequences. Here this is known to be linear convolution or linear correlation, right. and we can with that linear convolution you can observe that here the computational complexity will be like m times n plus m minus 1, and if there is we can able to evaluate the convolution and correlation using the another method known to be like a circular convolution or circular correlation. So, by using the circular convolution, concept of circular convolution, where this complexity can be reduced to m times n plus m times log m or m times log n plus n. It means that instead of the product is almost like n square complexity, order n square complexity, where that can be reduced to n log n, order n log n can be reduced by using a circular convolution and all. So, anyway, it is not in our scope, we are not discussing the concept of circular convolution. That is a method to evaluate a convolution, right, using the other way, which is computationally efficient. So, with this we will stop here. So, we will continue the other things like there is a concepts like autocorrelation, which is very important for speech in the context of speech. So, that we will just introduce in the next class. Okay. Thank you.